Welcome everyone. In this video, we are going to discuss about mathematical fallacy. So, what is mathematical fallacy? Fallacy is nothing but an invalid proof. So, we are going to prove something like this: 2 equal to 3, 5 equal to 4. How is it possible? Let's take some examples and try to understand. So, we are going to discuss about fallacy number 1. Minus 6 equal to minus 6. It's valid, right? What we can do, we can represent minus 6 as 4 minus 10 and 9 minus 15. This is also very valid. Now what we are going to do, we can represent these terms in this specific way: 4 as 2 square and 10 as 2 cross 5. Similarly, we can represent 9 as 3 square and 15 as 3 cross 5. Now what we are going to do, we are going to add 25 by 4 on both the sides. So I am adding 25 by 4 on both the sides. So I am representing 25 by 4 as 5 by 2 square, which is also a very valid form of representation. Now what I am going to do, I am going to multiply and divide the middle term by 2, which is also again going to yield me the same results. So 2 cross 5 cross 2 by 2, and here also I am going to multiply and divide by 2. So this can be represented in this form. It is like 2 square minus 2 into 2 into 5 by 2 plus 5 by 2 square. Similarly, this can be represented in 3 square minus 2 into 3 into 5 by 2 plus 5 by 2 square. If you remember the school days, this is a simple representation of a minus b whole square. So a minus b whole square is represented as a square plus b square plus minus 2ab. So this can be this previous term can be represented as 2 minus 5 by 2 whole square equal to 3 minus 5 by 2 whole square. So now what we are going to do, we are going to take a square root on both the sides. This will lead me to 2 minus 5 by 2 equal to 3 minus 5 by 2. So if I remove 5 by 2 from both the sides, it will yield me to 2 equal to 3. How come this is possible? Again, we are going to discuss about another fallacy over here. Similar type of a fallacy where we are taking minus 20 and minus 20. It can be represented like this: 25 minus 45 and 16 minus 36. And we are going to represent the 45 in terms of 4 cross 9 and 36 in terms of 45 in terms of 5 cross 9 and 36 in terms of 4 cross 9. Now we are going to add 81 by 4 on both the sides. So this goes like that, similar fashion whatever we did in the previous fallacy. So this is 5 square and 9 by 2 square, and this middle term I am going to add and multiply it by 2, so that won't yield any results. So it is like, it is again in the form of a minus b the whole square. So this can be represented in this fashion, and we are applying the same a minus b whole square formula, which will lead me to 5 minus 9 by 2 whole square is equal to 4 minus 9 by 2 whole square. So I am taking square root on both the sides, which will yield me to 5 minus 9 by 2 equal to 4 minus 9 by 2. So this 9 by 2 can be cancelled, which will yield me to 5 equal to 4. Again we are leading to another misconception. Previously we led to 2 equal to 3, now we are leading to 5 equal to 4. Similar way we can do lot of things using these sort of mathematical calculations. But where is the problem? What is the exact problem and where is the exact problem? You can pause the video and think through that. What is the exact place where we did the mistake that is yielding us to this type of results? We are 100% sure this is not possible. 5 is not equal to 4, 2 is not equal to 3. We know that very clearly. So where that exact problem comes in? If you got, actually the problem is in this step: 2 minus 5 by 2 whole square equals to 3 minus 5 by 2 whole square, where we are taking square root on both the sides. That will not yield me to 2 minus 5 by 2 equal to 3 minus 5 by 2. This is the problematic step. So what is the problem here? So in the case of fallacy 2, you can see the same thing: 5 minus 9 by 2 equal to 4 minus 9 by 2. We are taking the square root of the previous equation on both the sides. That is not the correct one to do. So what is the exact problem there? To understand that, we can take something like that. See, I am taking a square root of a square equal to square root of b square. This is what I am doing over there, right? We proved that a square equal to b square. So we are taking the square root on both the sides. This is possible. This is possible. It becomes square root of a square and square root of b square becomes a equal to b only when the sign of a and sign of b are one and the same. If you take the cases over there, previously one side is positive and other side is negative. So this is represented in this way, 4 equal to 4, but the 4 can be represented in minus forms as well, in the form of the squares. So it is minus 2 and minus 2 can be represented as 4, and 2 can also be represented as 4. Then it will lead to something like that, 2 square equal to minus 2 square. This is proper, but we know that plus 2 is not equal to minus 2. That is the problem which happens over there in all sorts of the equations. Now let us revisit that. See, we are taking the first case, 3 minus 5 by 2 whole square is equal to 2 minus 5 by 2 whole square. Till this point there is no problem. We know 5 by 2 is 2.5. 3 minus 5 by 2 will be a positive number, but in this case 2 minus 5 by 2, 5 by 2 is 2.5, 2 minus 2.5 will be minus 0.5, right? That minus is missing over there. So what we need to do, when we take the square root over there, we need to add that minus. So what it happens, 3 minus 5 by 2 equals, we need to add a minus sign. Since this is the minus negative number, we need to add a negative sign before that, and then it becomes 2 minus 5 by 2 if you take a square root of that. Then now what we can do, we can simply add 5 by 2 on both the sides, then it will come to a proper result. It is like this can be represented like this, and once you do the simple math, we will arrive at 3 equal to 3. That is the right thing. The major flaw there is the square root problem. When you are taking the square root of a negative number, we need to add a negative sign before taking that. So that is the key here. Say similarly for the second case, if you can take, this is the same stuff, 5 minus 9 by 2 whole square equal to 4 minus 9 by 2 whole square. Here in this case 9 by 2 will yield me to 4.5, 5 minus 4.5 is 0.5, but in this case 4 minus 4.5 is going to be minus 0.5. That is the problem. So we need to add a negative sign before. If you do the same sort of math, we will get 5 equal to 5. So the key behind all these things is that taking the square root of a negative number, right? So that is the simplistic stuff. This is a kind of a mathematical fallacy which I came across, so I thought of sharing this interesting stuff with you people. I hope this video has been informative for you. If you like the video, do share, subscribe and comment, and thank you very much for watching.